Now it shows. Okay, good. Okay, so what I will do is, let me once again, for the sake of completeness, let me once again start from the beginning, so that it benefits the students who are not able to join the class today. So we are going to cover the topic service and data management in cloud, and so these are the topics that we are going to cover. We are going to talk about resources, resource management, resource abstraction, and workload management. Thereafter, we are going to talk about load management, including all kinds of load, like computing load, traffic load. How do you manage? What are the different algorithms for doing so? Storage access protocols, you know, storing, so for accessing the data that are stored, there are different algorithms that are there. So what are those? We are going to look into those, and then the functions and benefits of services and storage. These are some of these different topics that we are going to cover under this module. So when you talk about cloud, right? So when we talk about cloud, we have already seen that the three elementary levels of service that are available are software as a service, platform as a service, and infrastructure as a service. So basically, it is all about services. It is all about services. So these services, computing services, these service requests, these come from different users, different customers, different consumers. These requests come from. So these requests will have to be processed. Just imagine that there is a cloud platform that has been set up. So you have a cloud service provider, CSP, you have a cloud service provider, and there are so many different consumers who are going to connect through the internet to the cloud platform. And the cloud service provider is the one who manages the entire show. So how things are managed, it's a pretty complex thing. It is pretty complex, so there are so many different sophisticated things that play a role in order to render these different types of services, like software, infrastructure, platform, and many others have also evolved over the years. To render all of these in a proper way, in an effective way, so there are so many different algorithms, so many different logics that will have to be implemented in order to enable this kind of service. So ultimately, what happens? So you have, through some internet portal, the consumer submits the different requests, right? So like this, you have thousands and thousands of consumers at the same time, having these requests, so not only thousands, actually, I mean, in public cloud you have, it is much more. So how do you manage this? So this is not easy, right? So what you need to do is that once these requests come in, you need to have these cloud resources properly provisioned in order to cater to these different requests. This has to be done in such a manner that the overall performance of the system from the cloud service provider viewpoint, as well as the performance from the consumer's viewpoint, these are managed properly. Okay, that means both the service provider as well as the consumer should be satisfied with the performance. It should not happen that because of so many different requests coming at the same time, for example, the system becomes too slow, and it can become slow for different reasons. maybe because the resources are not allocated properly, the resources are not available. Maybe the resources are allocated to someone, some for some requests the resources are available, made available, as a consequence of which for the other requests the resources are not available, or not available adequately, because of which the latter consumer request will have to be slowed down. So you see that it's a very complex thing. In the same way as in computer, uh, in operating systems, for example, you must have studied, those of you who have a computer science background, you have studied about resources, resource management, scheduling, job scheduling, task scheduling. So the same thing holds over here as well, right? But here we are not talking about a single operating system. Here we are talking about a mega show which will have to be managed adequately. So the complexity is much more. You have scalability issues which will have to be taken care of adequately. So you see that what we understood is that these services, the service requests that come from the consumers will have to be ultimately fulfilled with proper, quote unquote, proper performance, which will be satisfactory to both the consumers as well as the service providers. So before we look into this issue and dig further ahead, let us try to understand these two viewpoints, the consumer viewpoint as well as the service provider viewpoint, in a little bit more detail. We have actually, in different forms, we have in the past looked into these viewpoints, but let us do so once again so that we can understand this resource management issue properly. So you see, as you know by now, that from a consumer's viewpoint, the consumer has to offer multiple services, several services. Consumer has to not offer, sorry, consumer has to enjoy, consumer gets multiple services, scalable services, and these services are metered services, which means that these are going to be measured. So the number of units of these services are going to be measured, and the consumer is going to get billed accordingly. So from the consumer viewpoint, the consumer feels that the consumer has access to an infinite resource pool, right? Consumer feels that there is infinite resources that are available, and the consumer can use any amount of resource that he or she wants to. But actually, in practice, it is not so. You do not have infinite infinite resources. It is just the viewpoint. From the consumer viewpoint, you feel like you have this kind of resources. So you see that if the limited resources will have to be pretended to the consumer as if the consumer has access to these infinite resources, so this resource management that I was talking about so far is very important, right? So how do you adequately manage these limited resources? You schedule the jobs, you switch between these resources, etc. How you do this is very important. So, so that was from the consumer viewpoint. Now from the service provider viewpoint, actually there is finite amount of resources in the resource pool, and these resources will have to be served to large number of users, typically in a public cloud, right? So this optimal management of resources, which is also known as resource management in cloud computing, so this optimal management of resources is very important. So these resources will have to be provisioned in such a way that the overall performance of the system is so is optimized properly, right? So there has to be very reduced delay, and overall overhead from these computations, etc., will also have to be reduced, will have to be managed properly. So so what is for doing all of these, what is required is to have something called task scheduling. So task scheduling basically, so you see that when these service requests come in, so these service requests will have to be ultimately, will have to be broken down into different tasks, right? Ultimately, after certain number of steps, these service requests, they break up into several tasks. So like this, for not only one consumer, for several consumers who are trying to access these resources at the same time, you have multiple broken tasks from all these different consumers, right? So you have large pool of tasks that will have to be handled properly. But on the other end, for the service provider, there is only limited amount of resources. And on top, as I said, the performance will have to be maintained in such a way that the consumer will have to get a view, will have to get a feeling that there is infinite resource pool. The consumer feels like, as if, it's a dedicated resource that is given to the consumer. So how do you handle this? So that is where the issue of something called task scheduling, the issue of task scheduling and resource allocation, task scheduling and resource allocation is a very, very important topic, which is fundamental to cloud computing, right? It's a very important topic in cloud computing. So when you talk about these different types of resources in cloud, so from the very bottom, you see that you have infrastructure, platform, applications, as we have been seeing these terms so many times. So for infrastructure, you have compute, network, block storage. For platform, you have like this, object storage, identity, runtime, queue, data store. Applications, you have monitoring, content, collaboration, communication, finance. Collaboration, actually, there is a typo, so it should be double L, right? So collaboration. Um, so you have all these different, for these different layers or different levels of services, you have different types of resources which can be broken down into these individual components which will have to be managed. So for example, for infrastructure, you have compute is the fundamental thing, right? So compute means like this computing infrastructure, right? So basically the actual computing infrastructure that is part of this compute resource, right? And then you have the network is also part of, it's also a resource that will have to be dealt with. Then you have the storage. Now storage, basically there are different types of storage, and there are different types of storage mechanisms. So at the infrastructure level, basically it is the block storage that is very important. Block storage, right? So there are different types of storage, of file storage. Like this, there is block storage, there is object storage. Like this, actually there are different types of storage. So blocks, basically, when you talk about these storage in terms of blocks are basically, individual units. So these individual units will have to be stored, will have to be accessed, data will be stored in these individual units, and so on. So that is what basically block storage does. So in contrast to block storage, basically, object storage, what it does is it talks about these objects. Objects are basically the central entity, right? So the data are stored in the form of objects, right? So this is object storage. Then you have identity management. Identity is also a resource. So runtime, that means all these virtual machines, runtime, etc. So all of these queues, data store. So these are like different types of resources that are available. And on top you have these different types of resources, like finance basically talks about these pricing, etc. Monitoring applications, content creation, content monitoring. So like that, so there are different types of resources. These are only a few that have been named over here, but like this, there are different types of resources which will have to be dealt with, which will have to be managed, and the resources will have to be allocated in such a way to these so many several requests that come in, that the individual consumer from his viewpoint, from his or her viewpoint, the consumer feels like there is infinite dedicated resource for the consumer. Okay. Now, I already spoke in sufficient detail about these resources and resource management, right? So resources obviously will have to be managed. So, so let us go through this these few points to understand this resource management issue in a little bit more detail. So resource management here, actually we are talking about integration of heterogeneous resources in cloud to enhance the adoption of cloud computing by the service consumer, right? So how do you integrate all these heterogeneous resources? Not only heterogeneous resources, these resources actually they come distributed, right? So you have from different locations different resources, you know, being pooled and being served to the several consumers on the other end. So the advantages of heterogeneous resource integration are that there is support, wide range of application support. There is mapping between the application requirements and resource features or characteristics, and there is maximization of cloud service provider profit. See, this is one, and the second thing is that from the consumer viewpoint, there has to be maximization of the satisfaction. So the performance, these resources will have to be managed in such a way that the consumers will get adequate satisfaction of the services, of the performance of the cloud platform. And on the other side, the cloud service provider, the CSP, it is in business, right? So CSP is in business, so the CSP will have to ensure that there is maximization of its profit while ensuring maximization of the satisfaction and the performance of the system and the consumer. Okay, so let us now go one step ahead, and then we will talk a little bit in more detail about each of these. So cloud resource scheduler. So as you can understand that you have these pooled resources, right? From different sources, the resources are pooled, and there are so many different tasks that are coming in from map to the different service requests that come in from the consumers. So these resources will have to be scheduled and will have to be mapped adequately to these tasks, right? So how these cloud resources are scheduled? So the cloud resource scheduler will have to be built. There has to be some cloud resource scheduler. There has to be some cloud resource scheduler. So typically, in most of the publicly available cloud systems, there are three types of cloud schedulers. One is called the monolithic scheduler. The second one is called the two-level scheduler, and the third one is called the shared state scheduler. So you have monolithic, two-level, and shared state schedulers. So monolithic scheduler, as this name suggests, it is monolithic. Monolithic means like a single stone. So like one stone, you have monolithic, right? So monolithic scheduler, it's a single instance, and the scheduling is done in sequentially. So monolithic scheduler basically implements all policy choices in a single code base. So an example of publicly available monolithic scheduler is Google Borg scheduler. Google Borg. Google Borg is a monolithic scheduler. On the contrary, you have something called Mesos. Mesos is a publicly available scheduler which is not monolithic. It is called two-level scheduler. So this Mesos and other two-level scheduler, these are frameworks which can manage infrastructure and separate the application schedulers from the resource schedulers. You see that two levels of scheduling are taken care of. One is the application scheduling, the other one is the resource scheduling. Application scheduling, resource scheduling. So two levels of scheduling. So in the case of the monolithic scheduler, it was not like that. It was a single entity which was taking care of the entire scheduling tasks. So there, in a two-level scheduler, you have some, some centralized master scheduler that decides the number of resources from the available pool of resources that comes from distributed sources, and these will have to be assigned to a particular framework. And the application scheduler, it allocates these resources to each application within a framework. Okay, so this is basically how these two-level schedulers work. And then you have shared state scheduler, which supports multiple parallel schedulers. Shared states, the state is shared, right? So multiple parallel schedulers are supported by these shared state schedulers. And here each scheduler, it maintains a local copy of the global state for local decision making. So every individual scheduler, it's all like, they all maintain their own individual copies, and this globally at periodic intervals of time, the this local copy is shared with the global state, right? So that globally everything is updated, right? So in terms of the scheduling that takes place. So after each local decision, the shared copy of the global state is also updated, and the state synchronization is done, as I told you just now. Okay, so one of the publicly available shared state schedulers is called Omega, Google Omega. It is from Google, so it is Google Omega. It is a shared state scheduler. Okay, so these are the three things that yeah. So these are the three types of schedulers that I wanted to talk about today. Um, so now, yeah. Okay, so for today, we are not going to go any further, but I would like to show you some videos, um, you know, of some publicly available schedulers and more information so that you can relate to whatever I just spoke just now. Okay, so I'm just going to stop my sharing, and please turn off the video. Please turn off the recording.